whether my voice is okay. I can see the live chat, so you can put S towards. If it is okay, can you hear me? Okay, I can see. So without further delay, we just move to the topic. So myself, Vignesh, who is actually a teacher trainer, Ocean of Learning Institute. It's actually a program where the child will explore more about math. So first of all, I want to thank you all who are here, and I'm sure that you will be definitely taking the things which is going to be shared here to your class without any much alteration, so that I'm guaranteed, and I request you all to stay until the session gets end. So we will start with a thing. So everyone try to find. Can you all see that? Can you find the word behind that? Can you find? It's a kind of connection game. So there's a mathematics topic is behind it. Can you find it? I can see your live chat. So everyone can put yours. So what is the mathematics word behind that? This picture. Very good. MS primary. I can see it is symmetric. It's very good. Then the next one is this. Can you try it? Similarity. Wow, it's nice. Similarity. It's one way of symmetry. Can you all guess this? What is the word? So patterns. Wow, nice. Big circle. Think that is one word. Area and perimeter. There's a connection between these two pictures. Metric, measurement, coincide, symmetry, logarithm. Deepa Maria Varghese. It's really great. Now this is somewhat quite unique. We just give a try. We will have 5 seconds or like 15 seconds. Let everyone try to this. I can see Targis Krishnan, Divya Madam, Darshana Bones, all are saying it. Can you try this one? What is the word behind this? Don't worry, it won't be much kind of thing. So mensuration, fantastic. It is mensuration. So I request everyone to solve this. There's a reason behind it. So don't just think, oh my God, what I'm doing here. Right now we are solving many things like connection game. Now he's giving some problem. So try to solve this and put your answer in the chat. There is some discussion will be definitely happening now behind this. So what is 56 times 7? 392, 392, 392. Very good, I can see. Kalayarasi Sugi and Shweta Gamir, Raji Education, everyone are doing. So actually, there's a way to do it. You might have done this. How many people agree with me? You have splitted 56 as 50 and 6, and you have multiplied 50 and 7, and 6 times 7, and you got 392. How many people did in this way? Put yes in the chat. How many people did in this particular way? Those people kindly please put it in yes. Yes, Rupali Patel. Yes, RJ Education. Fantastic. Tanuja Chavan. So whenever we say this immediately, we all actually agree, right? So most of the Neetu Timan, Sonam Das, wow, fantastic. Divya Maran say no. Yes, there is a difference, definitely will be there. But what property is actually easier? Which property is used here? Which property? What's the name of the property here? We are using it. That is a property which in grade 6 we are introducing to the children. But whether they enjoy that, there is one property behind it. Factor of multiplication. The child never have any connection between the numbers. It sees just as the letters and some kind of procedures. They don't know why they are doing. Sometimes they will feel it like it's a kind of some procedural problem. How many people agree that? Whether the child enjoys while solving distributive property, whether the child is taking this tool as a distributive property as a tool to solve any multiplication problem in mind, or they're just taking this as a kind of problem which they have to do a lot of procedures? What is your opinion? Do you feel the child enjoys this distributive property when they are doing in the class? If you feel they're enjoying and they know how to connect with the children. So one small suggestion to everyone, and one thing which I'm requesting is, take this distributive property as a way to mental math. Mental math in the sense like how a child can do it in the mind. So I request they will search for an easy way. They think this is the only method. But I request everyone to take this property to do the multiplication in an easier way. So now you try this. Now come on, come on. Very good. I can see you interesting. All even working for a long time, you people actually came back to home and you are attending this webinar. Thank you so much. Try to solve this. What is 2 times 8 times 5? 2 times 8 times 5. Video is frozen. Okay, I will just video. One minute. I will just redo once again. Now is it visible? Sorry for the glitch. Now I think it is getting connected back. So can you see the screen? I would like to know, can you all see the screen? You all are actually doing 2 times 8 times 5 is equal to, there's some answer. How many people did in this way? First you multiply 2 and 8. Thank you so much. I think now it's get back. So what is 2 times 8? And then you got the answer. How many people did in this particular way? How many people think this is the way the child also is going to do? Did you do in any other way which makes your job easy? And there is also one property is hidden behind it. Can you put it in the chat? Yeah, fantastic. Ms. Tarageshwari Krishnan has put it. Associative property. First, they have to know how to associate the number, how to connect, how to create a connection between the numbers, meanings. So then naturally the child will enjoy the process. 2 times 5 is 10, 10 times 8 is. But when a child approaches this problem, they will start first 2 times 8, 16, then they will move on. So I request everyone here, take these properties as a way to mental math. Then why so many students are afraid of math? So I will show you one picture. So generally math leads to anxiety. It's a kind of thing is there common to everyone, right? So now in this session, we are going to address only one thing. I have a hint here. Among the, you can see many problems in this picture. Among this, which one do you think the children feel it harder? I mean, which arithmetic operation, among which arithmetic operation they feel it so hard to solve it? Which arithmetic operation they find it so hard? Can you put it in the chat? So here you can see 17 plus 2, 6 plus 8, these things. But among this operation, addition, subtraction, multiplication, division, which one do you think the children will find it so hard to approach, hard, even in grade 8, grade 9, even in grade, any grades? It's very common. Division, Sonam Das ma'am said, video passed. Now I think it's good. Dhanuja Jagan, Shris Sharon, yes, it is obviously division. So today you all will take one thing that is sure. One is how this division can be playful. So before to proceed that, so you all know division. Thank you so much. You all are so engaging. Now, what is 0 divided by 5 and 5 divided by 0? We asked to children, what they will say, 0 by 5 is 0. 5 divided by 0 is infinity, not defined. But why? If you ask 5 divided by 0, not defined, and 0 by 5, 0. If you ask a child, what the child will say? The child will say, generally, I don't know. It has been told. Am I right? Is there any possibility how we can make this division in an easy way? That is, you are going to learn experiments. I'm going to share with you, and you're going to learn from this whole webinar. It's going to getting. I'm just sharing this idea. So now we'll just proceed. What are the common errors the child will do, and how can we do it? So I'm just taking with one example. I hope you all can see the example. We are not going to solve it, but we are going to see the process of solving. So generally, the child will see the question like this, and it is known as long division, change into multiplication. We can't make zero groups, infinite is the answer. Fantastic. So this a child will do. The child will see 9 threes are 27, and child will write remainder 0. Now the confusion starts. What to do next? The child will write quotient as 3, remainder as 6. How many people in this right now, how many teachers have seen this kind of problems and this kind of answers from the child in your classrooms? How many people think, yes, quotient is 30, I agree. But how many children do this mistake? We are going to find the root cause of those mistakes, and we are going to rectify using some methods which will be definitely going to solve that, and they will enjoy the division in their life. So how many people think that you also have seen this kind of response? The quotient as 3 and remainder as 6. Sharon ma'am, Jayalakshmi ma'am said yes. Priyanka Arora ma'am said yes. Yes, they do. Yes, ma'am. So many of them are actually doing maximum they are doing. So why? Then as a teacher, what we will be saying to them, write 0 here. Many times, even though we tried saying 9 times 0 is 0, in 6 we don't have 9, so we are writing 0, but still the child has confusion why I want to write 0. So this is a one common error among the child. So on the end of this webinar, how it is going to be addressed. The second one is, you all can see the next question. It's a kind of thing. What is the toughest task? What do you think from this slide? The child feels bored or hard to do that. What is that? Which one do you think the child feel it harder? Among in this slide, there is one thing the child will feel it. Why I have to do that? Oh my God, it's boring. What the child will generally feel it hard, and generally what makes the child to solve this problem hard, which is in some color metric measurement topic. Okay, 35 tables, fantastic. Veena Naik ma'am said 35 tables definitely will make the child to see why I have to write the whole table and why I have to write it. So what will child do? They will write the learn, right? They will write the tables and they will start writing 35, 1 is 35, and they will subtract and they will just move on slowly. Here, the slide which I'm going to show is there's a next process, but as you said, writing the tables is another way where we teachers will try to make the child to learn, but child literally feel it why I have to do it, and child feel it so hard, and from that moment the child will start thinking, oh, division is the toughest one, so it is not my cup of tea. So they will move on and they will start saying, oh, I don't know division. They won't say, I don't know how to do it. They will say, I hate or I don't like math itself because of division. It is very true. So this is the second thing which you have discussed. So the last one, 2025 divided by 5. So as a child, what will be the mistake? What do you think? As a child, when child approaches this question, what are the mistakes the child can do? What are the mistakes the child can do? So you know the answer because we all as teachers and we are doing it for many times and we know the feel of it. As a child, the child will commit mistake like Ammi Trivedi ma'am said 45, unique versatile ma'am said 45, zero will be missed. Shubham Lokesh ma'am, very good. Not write zero and 4 not 5 quotient is 45, 45, 45, 45. Will not put zero after solving 20. It's fantastic. That's very true. Why child misses zero? We will see one by one now why the zero actually missed. Or if you ask the child will be asking why I want to write zero there. Is there any reason? Even though we try to explain them, they will be having a question like why I have to. So for the audience, the people who are joined now, as well as just to say what we are discussing as a summary. So first thing we started thinking addressing about the child is confused about what to do next, whether to mention a zero here, why I have to mention a zero. Because in this question, if you notice, 9 threes are 27 and 6 will be dropped and the child will write quotient as 3 and remainder as 6. So this is a one common error which the child do and where we have to address, where we have to strengthen their understanding. So whether to mention a zero, what I have to do next, this is one thing. Next is they will struggle to write a table and they will think, is there any need of that? They don't find it interesting. So this is the second one. The last one is the child doesn't understand why a zero need to be placed in the middle. So these are the three areas where we are going to address. So in division, I'm just saying once again, because everyone will get a clear picture why that zero I have to place it at the end. Is there any need? The child will leave it and will say the answer is 3 and 6. The next one is tables. The 2-digit devices, 3-digit devices will make the child to put it into a lot of worries and they will find it so hard and they will start saying math, I don't like math. The last one which you are going to address here is why I want to mention a zero in the middle. What is the reason? So they have a confusion because I know tables are important. Tables are very important, but I I have one method which I have observed and I also tried in my class. I will going to share that shortly. So how many people are willing to know what is that method and how we can take into the class? If you're really feeling it, please put a yes in the chat. How many people are willing to know how can we address these three issues? Can you please? How many people willing to know the method? Please put yes in the chat. Yes, sir, sure. Yes, yes. I'm interested. Yes. See, this is a game. It's called banker game. So it's very simple. It's not the real money. It's actually the money. It's a kind of currency like dummy currencies, which is available in Amazon, in Flipkart, all online as well as we can get from some shops, stationery shops. So this thing is going to be a game changer, definitely. For example, how we can play this game, how you can make this game as a way to learn division. So that is what I'm going to say. So how I'm going to say is like, imagine there is a 685 rupees. Just take this money and give it to a child and ask the child to share among 5 people. What the child will generally do is, first imagine he is having 500. So a child will share each 100 to each people and remaining will be 185 rupees. Next, child will see the 20 rupees and each 20 will be given to 5 members and So 85 rupees will be left, and 10 rupees will be given, and 35 will be left, and 5 will be given, and 10 will be left, and 2 rupees coins. Now the child, allow the child to go and note down how much money is there with each person. Sir, is it a, it looks like a simple thing. How this is going to give a big change in learning division? What I request is allow them to play at least for 1 week. Don't say anything to them. Don't say you're going to learn division after this. Just it's a banker game. Sometimes the child may not have a exact change. They might have 200 rupees, but they want to convert into hundreds, or they want to convert into 50. Allow them to go to the bank. It's a kind of place. Bank in the sense it's in a classroom, create a banker game. So where a banker will be having a lot of currencies, and that person is going to give some money to the person and ask them to distribute to some number of students. In this case, we have taken 685 rupees, and it is being shared among 5 people. So what the child will do is naturally the child will come back. Banker, I don't have the exact change to share among 5. So let them get exchanging the money. For example, they will give 500 and they will get 500s. Sometimes they will give 200 and they will get 450. These things will be keep on happening. So the child will get a kind of intuition towards division. So from that moment, what the child will start doing is they will have a way, it's long, they will create a bond towards operation division. So how we can write it? I just said it's a game. After a week we played this game, we will just step into this division called flexible long division. So how this flexible long division, I want to know how many people are aware of this already, flexible long division. Before proceeding forward, how many people already have an idea about flexible long division? I just like to know, because I know these are things not so, it's not invented, it's just been discovered, and we are sharing it. We want to make the idea behind this webinar is to make math education beautiful. They have to enjoy, the child has to enjoy. No idea, nope. Sonam Das ma'am said yes. Emmanuel sir say yes. Sonam, no idea, no. Nal Banerjee ma'am saying no. So to make many people aware, I request everyone take this and share with your community teachers, and kindly make this division. At least we will take a kind of mission within 2026. Everyone in our school should be good at division concept. They should not afraid of it. Tanuja Jahuman ma'am saying yes. No sir, willing to know. Sunisha ma'am, yes. The quotient will be in the form of addition. Shweta Gambhir ma'am saying, many are saying no. So this no is a kind of sample we can take it, and we can start promoting to the teachers, because this is a great platform where we are right now. We could share our ideas to everyone. From here, I request everyone to take this to exponentially. So without further discussing, I just proceed. What is flexible long division? Generally, the child will feel so comfortable in table, that is 5 times 10 is 50. 5 times 1 is 5. 5 times 100 is 500. Even in the class, as we having some kind of compartments, like saying he's a slow learner, average learner, everyone, but it should not happen in our class. We will discuss time permits. But in our class, everyone is comfortable with what is 5 times 10 is 50. So this is how the game is going to proceed. So when we show 5 times 10 is 50, next again in 135, the child, no, 5 times 10 is 50. So again, the child will do 5 times 10 is 50. You can see at this place, in this 35, how many 5 is there? Child knows 5, 6 or 30. And now, if you see one more time, we have 1 5 here. Even here, you might ask, so is there anything like why can't a child can write? Can a child write 7 here? Yes, obviously it can write. But what is the difference between the long division, just a procedure, and this one? Here they won't subtract, or they won't see 1 as 1. They will see 1 as 100. Here, if you see there's a 185, they will see this 1 as 100. They will never see this as a 1, and they won't say this is 18. 5 3s are 15. They will subtract 3. That will never happen here. They will see the value, real value. We no need to emphasize this is a place value here. I will show you some more examples to get a better understanding. But here, how many people at least getting an idea over that? Because before proceeding, could you getting an idea how we can actually take to the class? 5 times 10 is 50. Yes. Please put in the chat like thumbs ups or heart things. You please put that so that I can understand how many people getting this. How many people feel it is something new or something unique. Definitely the child can understand easily. Or you do you have any kind of questions like still I think this is not so good. How many people thinks if you think this method is going to be a game changer, but yes, exactly, it's a repeated subtraction, but the child will feel comfortable because we are not forcing them think in 18 how many 5 is there. We are not saying, we are just allowing the child, you go with whatever the table, 5 times 10, you can just proceed. It's too long, yes, that's why, in long division what will happen, the name itself long division will be there. Yes, it's too long, but slowly we can take a child towards the procedural. It is not, I'm not going to say this is the only method a child can do it. How many digit to take at one time, to decide how many digit to take at one time. Okay, I think Zunejam, I'm saying how a child can decide. It depends. For example, here in this place, 185 is there. So child 555, we will take, that is easy for a child to connect. So in that case, the child will go with 5 times 10, 50. Imagine this is 1850. Then a child can go 5 times 100. Uh, 0, they confuse long division or flexible function use. See, from when we can start this, from at least grade 3, grade 4, whenever we going to introduce division in grade 3, grade 4, we can play the game. For example, the whole year the child can play grade 3 division banker game alone and never do anything in notebook. I mean, the procedural method we are not going to teach. In grade 4, we are going to introduce flexible long division. Naturally, anyone in the class, or maybe some of them in the class, they will start saying, sir, why I want to write 5 times 10, 5 times 10, 5 times 10. I know it is 5 times 30 is 150. I will go with that. In this case, they will not miss that 0, those things. I will show you slowly, you see. So if possible, you all can take some pencil or pen or some paper and try this, the flexible long division. Literally, you try it, because until we experience it, we may not feel it is worthy. Without experiencing it, we can't even convey to the children or students. So I request you to just experience it and work on that. In this case only, see this beauty. Imagine a child is solving 6428 divided by 35. Definitely the child will feel it hard and it will stop. Even you will never try to approach it also, because the 4-digit dividend and 2-digit divisor will make a scary part to a child. So that is the reason why we are stressing, why can't we do this? Can you all see this? How a child can have a lot of flexibility, no restrictions here. It depends on the child's ability. Simple division is easy than long division. Yes, definitely you can actually have a division. Long division is it's a kind of word that makes it hard. So here the another example is being shown for the better understanding. You can see that. So 4 times 50 is 200. Here the child is not saying 4 times 10 is 50, 4 times 10 is 40, again 4 times 10, 40. Now child, after doing so many times, the child naturally sees 4 times 50 is 200. So, but we will have time to do with time constraint to complete syllabus. Exactly. I will come to that part. Definitely I will address this, Divya Chandran ma'am. Whether this is going to be helpful, because there is a time constraint is there to complete the syllabus. So these are the question I just thought of asking you to try. So I will say that completing within a time, but think why a child again commit a mistake in grade 8, even though we completed our syllabus in grade 6 or grade 5, grade 4. Why a child commits a mistake in grade 10 also? Then there is something missing in that understanding part. So if we take time now, then I think that will help a child to uh, understand, and it will rectify the mistakes later. So I request, I know it's very tough, but still, but syllabus it gets difficult. I know syllabus is there, time is there, but still I request you can proceed. See, I want to introduce one more thing. So this is the one takeaway you all can have, the flexible long division. And the another one is the word how many, how it is going to change. I will say that 20 divided by 5 is equal to 4. If you say this to child, what is the answer for this? 20 divided by 5 is equal to 4. What is the answer? We will be saying 4, right? And we will be asking the child, imagine how many 5 is there in 20. This is the way we are going to change our approach. See, 20 divided by 5, we say, they will say the answer 4. But imagine if you are asking how many 5 is there in 20. It is difficult. It is different for different students. Exactly, I know. But I will just suggest here why this is going to be a game changer in learning division. Because when you ask how many 5 is there in 20, the child literally knows there are 4, 5 is there. So here after requesting, don't use the word 20 divided by 5. But now you will be getting a point. Use the word how many here. How many 5 is there in 0? The child will understand it is 0. How many 0 is there in 5? Or how many 0 is required to make 5? How many 0 is required to make 5? Naturally, we can't define, because even though if you're writing the 0 for the whole life, you can't reach 0. You might be thinking, sir, I don't know how it is going to help, but I will show you one example. Definitely you will rethink, reconsider. See this question. 1 by 2 divided by 1 by 4. After seeing this question, how a child will approach, how we will think, how we will solve generally. Because I have moved from flexible long division to now this division. Now see this, how a child will do. They will do it like keep it, change it, flip it. This is the method they will do. And they will say, if you ask you, why are you doing in this way? They will say, I don't know. But you ask one question and you all try it. The word how many, how it is going to be a game changer. How many quarter is there in a half? How many quarter is there in a half? Do you really feel it? Some difference is there. Something is visualizing before and after. When I say 1 by 2 divided by 1 by 4, do you really feel, could you visualize anything in your mind? But when I ask you now, how many quarter is there in a half? Reciprocal we teach, I understand. But what I'm trying to say is there, how many quarter is there in a half? When you ask this question to a child, the child can easily connect it, and it knows half is made up of 2 quarters. The answer is 2. But if you ask 1 by 2 divided by 1 by 4, naturally the child will do it like keep it, change it, flip it, and they will cancel it, and they will get the answer as 2. Now you think, don't solve it using any reciprocal or keep it, change it, flip it method. Now think, how many quarter is there in 3/4? What is your answer? You just listen to my, or don't do anything in your notebook, or don't try to do it in your mind like reciprocaling it. Can you visualize how many quarter is there in 3/4? How many quarter is there in 3/4? This word I'm just requesting. Take this word for teaching division. How many quarter is there in 3/4? Because 3/4 is made up of 3 quarter. And so regarding division, two things I just want to summarize it. Like one we have taken about flexible long division. Definitely that will be worthful. You take to your class. Definitely you will see a lot of changes, and we will rectify those three errors which we have discussed earlier. And this word how many will make them understand in a better way. And now you see these are the puzzles. You have mentioned the topic is fun and learning math through play. How the play will happen here. These are interesting puzzles you can find. You can take a printout of this and give to your students, and allow them to solve. Definitely they will enjoy. It will increase their number sense, because I will show the answer. Can you see? Can you say what is the answer? What answer it has to come here? 2 minus what it has to be placed. Can you see it's a 4 by 4 Sudoku, but it is become as Calcudoku. You just search about it and you can try it. Here the rule is, can you see the dark lines? So it is 2 divided. It means 1 and 2. When you divide 1, 2 by 1, you will be getting 2. So here 7 plus means 3 plus 4. 3 plus 4 is 7. So in such a way they have to arrange it. It's looking like a Sudoku, but it's Calcudoku because there are a lot of calculation is involved. So what are the numbers? 3 and 1 exactly. Now how many people know Diffie game? This will be an interesting game for doing subtraction, because when you ask a child what is 3 minus 2, 5 minus 6, or like 4 minus 2, if you keep on asking more number of questions related to subtraction, the child will feel it like I'm solving more questions. Why I have to solve these many questions? But if you allow to play a game like this Diffie game, I will explain how this Diffie game will work. This is a kind of things picture. You can take it as a template and you can see the example. At this corner you will start with a number. First you will be writing 32, 9, 14 and 3 as a random number. You can choose any random number. It doesn't mean you have to write 32 and 9 here. Then you find the difference between 32 and 9. You'll be getting 23. Then you find the difference between 32 and 3. You'll be getting 29. Then 3 and 14. The difference is 11. And 14 and 9, the difference is 5. So this is the way how you can actually proceed, and naturally what will happen, then you find the difference. So it will definitely reach to 0, 0, 0. So you ask the children to find a diffie which has more than 4 or 5 times, and you ask them whether there is any never ending diffie game is there, never ending. Let them choose any number, even 3 digit, 4 digit, whatever. So this is a second game you can take. The next is killer Sudoku. So it's a kind of Sudoku, but it's something killer. The reason is it will be a little bit challenging and curious to a child to explore about it. You can see here 13 is there, 3, 1 and 4. So what is the number? What number has to come here in this place? In this place, what is the number it has to come? You all can try it. So what number do you think in this place is missing? Is it visible for you? You are teaching this in your 4th class. Wow, super. So take this killer Sudoku to your class and complete. Complete. I will show the answer. You will understand it better. This is also an interesting thing where the child will engage in an easy way, and you can also make the child to think in different possibilities. There is no restrictions over that. You all think that how it is going to work. Can you see this complete? But these all things has to be turned as a kind of worksheet. Don't give them as any kind of digital tool, because it is very tough for them to get it back. So I think I'm just recalling that, like Calcudoku, and you can take Sampli and Kakuro. So this is a kind of place now. Why I'm sharing these all puzzles and interesting things, because the child needs some challenging and exciting things. These things will definitely give them. So how to use Complete? I will explain that. How to use Complete. Complete is a concept. For example, if you see here, there is a number along this row and along this column also. So you have to add 2 and 8, you will be getting 10. So you have to delete which is a not relevant number to be there, because you should get the sum along the row as well as the column. So you should find which is not required in this, so that the child will be interested to know what are the possible ways to connect it. So this is actually complete. So complete, and we have Kakuro. Kakuro is like you can use 1 to 9 number, any number, like 1 to 9, you can use any number of times. There is no restriction whether I have to use only one time or two time. It's no restriction. You can use 1 to 9 any number of times. But the challenge is here 7. So how I am going to place a number here so that I have to get 7 as a sum. Here all the thing is like addition operation, but there are a lot of logic things behind it. It will improve their ability of reasoning and logical thinking, and we don't need to make them to solve. Like for example, practice makes perfect, or more practice will make more math education, like they will better at math. But these things definitely will make them to do it with a lot of interesting. And the final thing which I have to focus is, I said play, 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 but do you agree whether our children are playing enough? What do you think? You all are looking your classrooms, whether children are playing, whether they have, do you find it obese is there in your classroom? What do you think? What is going to happen in the upcoming generation? Their health, it is going to be definitely affecting. How we are going to address? Because obesity is there, not their mistake, because of our way of living change their way of living. That I have to say. I know here some of them are like parents will be there, obviously. How many parents? I'm not saying that. I'm just asking in a way like how many parents spend at least 1 hour, 1.5 hours physically taking your child to some places and playing with them. And I have literally seen many parents making the child to eat their food, they're giving the mobile phone. Actually, there's a one autism, virtual autism is being raised. So I request, please avoid that. Now, how we are going to address childhood obesity? So there's a concept called math and movement. In that, health should be the first priority. That should be the first priority for us as well as for our children, students, for our family members. So take this. Play makes health, gives health and hope, everything. So just to summarize it, what are the things we have discussed here? First, we started with division. In division, there's a magic word called how many. Please use it. Definitely, you will enjoy that. How many quarter is there in 3/4? How many quarter is there in half? Those words will give an idea. Later, let them solve any kind of problems. Then flexible long divisions and puzzles. I have shown Kalkudoku, complete, and finally I have shared about math and movement. So what I want to say here is the way we introduce the concept to a child matters a lot. So I request everyone to try it on your own pace. Try to use these ideas in your classrooms. And I'm so happy to discuss further about this, how it happened in your class and what are the struggles you have faced. So I'm sharing my email ID and my contact number. You can see my contact number and email ID so that you can reach me, and you can post your things, your experiences and your ideas. And I'm happy to collaborate in a way like to work for betterment of math education. So we will discuss further. Uh, Thank you so much for this opportunity. Any questions is there, we can take ahead. So finally, which I want to say is the way we introduce the concept to the children's matters a lot. Take health as the first priority. So this is my email ID and contact number, and I request everyone. Thank you so much for staying for the whole 50 minutes still, and post your questions in the chat option so that we can take it forward.
Uh, Mr. Vignesh,
Yes, sir.
yeah, so we have got a question from Divya ma'am. She's asking that um So we have like they have time constant for completing the syllabus. So
Yes.
how the teachers are going to go ahead with this math and play together to and also finish the complete the syllabus. So if you would like
Okay.
to say something
Yes,
about
sure,
it.
sure, sure. See, definitely, this is a generally we will say it's a constraint. How we can actually address it? The one thing is math and play is not actually, it should be a different set. For example, inside the class, we will be doing lot of uh, rigid works or clerical works in the sense like procedural things, and we will go out of the class and we will play. It is not the way it has to be taken. Uh, if we take every year one thing as a highlighted topic, for example, in grade 2, let it be addition. The child should be so good at addition. In grade 3, the child should be good, doing good in multiplication. Then grade 4, uh, subtraction. Then grade 5, division. If you take every year, the child should be good at. I'm not saying we are not going to teach the concept in grade 3 also. Multiplication will be there, addition will be there. What I'm saying, we have to pick one concept and we have to check thoroughly whether a child is moving in a way that understood that particular topic thoroughly. So if we do in such a way, when they move to grade 5, then grade 6, when they enter, there will be no mistakes in arithmetic. Then we can go ahead in grade 6 fractions or integers can we take. In grade 7 fractions we can take. So if it's a slow process, it should be a lot of weaving around the all different grades. So if you do that, the time constraint will be reduced slowly. But at a stretch, if you think there is an issue among the time syllabus completing and time constraint, but if you do in this way, definitely it will be helpful. Thank you.
Thank you, Vignesh, Mr. Vignesh. I hope Divya ma'am got you got your answer. I'll take another question from Malti ma'am. She's asking that in direct method, what to teach them about zero? If you can
Sorry,
briefly answer that
their
question.
method to is their method to teach them about zero?
Yeah,
Okay,
what to teach them about zero when it comes to direct method?
okay. In division, they are asking about division, right?
I I think about the division. Yeah.
Okay. So in that case, actually they can ask every time how many questions. For example, I will take that question. Can we share it?
Yes, yes, you
Can we
can
share our
share your
PPT?
screen.
It is not. I'm just sharing on screen. So in this case, how actually this zero can be taught in the division method itself, like 2025 by 5. So we have to ask every time, like we generally the child will write how many one time to two times one, or like they start with one two is two, two twos are four, three twos are six. Rather, we can ask the children to write zero times. 2 is 0, 1 times 2 is 1, 2, 2, 2 times 2 is 4. If we say in such a way, then we can ask the child, here you can see 2. In 2, how many 0 is there? How many 5 is there? 0, 5. So they will be writing 0 and they will proceed. It will get 20. Next, in 20, how many 5 is there? 4. Then they will get 20 and 0. Then they will drop 2. And in 2, how many 5 is there? 0. This is why I'm just highlighting that how many word will definitely make them understand why they put 0 and why they didn't. Why they, for example, in first case, they didn't, they will be struggling to mention a 0 at the end. But if they keep on asking how many every time, they will never commit any mistakes. So how many is a word which they can take it. Thank you, ma'am. I think
Awesome.
I addressed that.
Yeah, I think Malti ma'am also got her answer about the question. The next and last question I'll take from Nalini ma'am. She is asking that how to introduce puzzles in the classroom.
Okay. See, actually, this puzzle should not be a separate one. Take this to your question paper, and I will give you one beautiful approach which I recently experimented, and it's really giving a great idea about the math learning and how the child actually thinks. These puzzles we can take it into our worksheet. Generally, as math teachers, we'll be giving a lot of worksheets. And what approach I'm speaking about here, the beautiful approach is make a child to write the reason for every question. From grade 5 or grade 4, even in grade 3, if you could start, it's I'm so happy. And what I'm saying, trying to say here, make a child to write reason here means in multiple choice question, there will be four options. The child will choose any one, and the child might, there's a chance of choosing it randomly. So we don't know why a child chooses. So allow the child or ask the child to write the reason for choosing it, why you have chosen this particular option, and be clearly informed to the child for your reasons. We will never reduce the marks. So let them get the confident. They don't get scared whether my reason is wrong, and they will reduce the marks. Don't do that, because that will give you a better clarity. Even in true or false question or match the following or even any questions, ask them why you did and how you did and what you did. Let them write it as a sentence. I know it will take time. For example, the 1 hour examination, it can have a 1 hour 15 minutes, 1 hour 20 minutes, but this will improve their writing skill, their thinking skill. And the beautiful part is we will understand why the child do that, as well as even sometimes parent will be asking, they will show the paper to you and ask why my child did mistake and what is the wrong in that. The child itself will understand better, because after the examination the child will forget what the child has done. But if this approach is there, whenever they see the paper, question paper, the answer script, they will know why I have written this. Oh, this is a thought I have done during the examination. So this is giving a mind-blowing idea about the child's thought process itself. So I request everyone to take that and experiment it. The reason. So write the reasons, so that they will definitely ask them to write the reasons. That will be a great help. And puzzles, you can take it like we have a kind of notice board. We used to place a math corner. The puzzles will be placed there in every classes. And even you ask the children to bring some puzzles, they will be happy to solve it. But don't take this separately. Just put everything into your worksheets and the question papers. Let them, it's part of us, not a kind of separate element. Thank you.
Thank you so much, Mr. Vignesh, for this very good, amazing session. And also, we saw like all the teachers, all the audience, the way they were interacting with you, engaging in the session with you, along with your practical, explanation with your presentation. It's really good to see all the teachers engaging together. For the teachers, if you have registered for this session in our center.org website or app, you will get a record of participation for this session. If you have not registered it yet, so I would request all of you to go and register, and you will get your record of participation there. For that, you can get it from our app, or you also get it from your account, center.org account. Thank you so much for participating here with us, with Mr. Vignesh, and also with Centa. Thank you so much for participating in this session. I hope you have enjoyed a lot. With a lot of fun, you have got a lot of different perspective about math, and I hope that will definitely help you in your classroom. Thanks again. Thank you, Mr. Vignesh, again. Thank you all. Thanks to all of you for participating in this session. Thank you. Have a very good evening.